There's a sound that NASA doesn't want you to hear, not because it's classified, not because it's dangerous, but because once you understand what it means, you'll never look at the night sky the same way again. In 1977, scientists at the Big Ear radio telescope in Ohio picked up a signal from space. It lasted exactly 72 seconds. It was 30 times stronger than the background noise of the universe, and it came from the direction of the constellation Sagittarius, over 120 light-years away. They called it the wow signal because one of the scientists literally wrote "wow" on the printout. To this day, we have no idea what caused it, but here's the thing that keeps me up at night. That signal? It's not the weird part. The weird part is what we call the Great Silence. See, when we look up at the stars, we see billions of them. Our galaxy alone has somewhere between 100 to 400 billion stars, and current estimates suggest there are around 2 trillion galaxies in the observable universe. Do the math on that, and you get a number so large, it becomes meaningless. There should be millions, maybe billions of civilizations out there. Some of them should be far more advanced than us. So where is everyone? Why is space so quiet? This isn't just the Fermi paradox. This is something deeper, something that I've spent years thinking about. And the more I learn about what we're actually detecting in space, the more I realize that maybe, just maybe, the universe isn't silent at all. Maybe we're just not listening to the right things. Or worse, maybe we're hearing exactly what we're supposed to hear, and someone or something wants to keep it that way. Let me explain what I mean. When we point our telescopes and radio dishes at the cosmos, we're essentially looking back in time. Light travels at a fixed speed, about 186,000 miles per second. Fast, right? But space is so incomprehensibly vast that even at that speed, light takes years, decades, centuries, even billions of years to reach us. When you look at the North Star, you're seeing light that left that star around the year 1380. When we look at the Andromeda Galaxy, we're seeing it as it was 2.5 million years ago. When the James Webb Space Telescope captures images of distant galaxies, it's looking at light that began its journey over 13 billion years ago, less than a billion years after the Big Bang itself. Here's where it gets strange. If we're looking back in time, and the universe is 13.8 billion years old, then any civilization that evolved even a few million years before us, which is nothing on cosmic timescales, should have had enough time to spread across entire galaxies. They should have built structures we can see. They should have left traces, signals, evidence. But we found nothing. Radio silence. Complete and total silence. Unless we haven't. In 1967, a graduate student named Jocelyn Bell Burnell discovered a strange repeating radio signal coming from space. The pulses were so regular, so precise, that her team half-jokingly called it LGM-1, Little Green Men 1. Turns out, it was a pulsar, a rapidly rotating neutron star that emits beams of radiation. Natural phenomenon, case closed. But here's the thing about that discovery. For a brief moment, serious scientists considered that it might be artificial, that someone might be broadcasting to us. And they weren't crazy to think that. Because there are other signals, dozens of them. Fast radio bursts, or FRBs, are one of the most mysterious phenomena in astronomy. They're incredibly powerful bursts of radio waves that last just milliseconds. Some of them repeat in patterns, some don't. We've detected hundreds of them. In 2020, astronomers discovered FRB 180116, a fast radio burst that repeats every 16 days like clockwork. Then there's FRB 121102, which not only repeats, but does so from the same location in a distant dwarf galaxy 3 billion light-years away. Natural phenomenon? Maybe. But the precision is unsettling. Then there's something called paratrons, mysterious radio signals that were detected by the Parkes Observatory in Australia. For years, scientists thought they might be coming from space. Turned out, they were coming from the facility's microwave oven when someone opened the door before the timer finished. Kind of embarrassing, right? But it highlights something important. We don't always know what we're looking for. We don't always recognize the signal in the noise. And that brings me to the most terrifying thought of all. What if we've already detected alien civilizations? What if we've been receiving their signals for years, but we don't recognize them because they're so different from anything we could imagine? What if their technology is so advanced that their communications look like natural phenomena to us? Arthur C. Clarke once said, "Any sufficiently advanced technology is indistinguishable from magic." I'd add to that, any sufficiently advanced technology might be indistinguishable from nature itself.
Think about it. If you showed a medieval peasant a smartphone, they wouldn't see technology. They'd see a glowing rectangle that displays moving images and produces sound. They'd call it a scrying glass, a magical artifact. They wouldn't understand the satellites, the cellular towers, the silicon chips, the code. They wouldn't even know to look for those things. We might be that medieval peasant right now, looking at fast radio bursts and pulsars and cosmic microwave background radiation, thinking they're all natural, when in reality, some of them might be the equivalent of alien radio stations, or navigation beacons, or quantum communications, or something we don't even have words for yet. But the silence gets even stranger. In 1977, the same year as the WOW signal, NASA launched Voyager 1 and Voyager 2. Both spacecraft carried the golden record, a time capsule of Earth, meant for any intelligent life that might find it. Music, greetings in 55 languages, images of our planet and our people. Voyager 1 is now over 15 billion miles away from Earth. It's in interstellar space, the first human-made object to leave our solar system. And as of right now, it takes about 22 hours for a signal from Voyager 1 to reach Earth. Here's the creepy part. Voyager 1 has been sending back data that doesn't make sense. In 2022, engineers noticed that the spacecraft's attitude, articulation, and control system, basically the system that tells Voyager which direction it's pointing, was sending back garbled, impossible data. The spacecraft was working perfectly otherwise, but the readouts suggested it was in a location it couldn't possibly be in, oriented in a direction that defied physics. NASA eventually figured out the problem. One of the systems was corrupted. But for months, Voyager 1 was essentially lying to us about where it was. Now, I'm not saying aliens hacked Voyager 1, but I am saying that our first emissary to the stars started malfunctioning the moment it left the solar system and entered true deep space. And that makes you wonder, what's out there? The Great Silence isn't just about the absence of signals. It's about the presence of something we can't quite explain. Anomalies, glitches, patterns that shouldn't exist. Let me give you another example. In 2015, astronomers noticed something strange about a star called KIC 8462852, better known as Tabby's star. The star's light was dimming in bizarre, irregular patterns, sometimes by as much as 22%. That's massive. No known natural phenomenon could explain it. Some scientists proposed that it might be a Dyson swarm, a megastructure built by an advanced civilization to harness the energy of their star. The idea is that an alien civilization might construct thousands or millions of solar collectors orbiting their star, and when those collectors pass between the star and us, they block out the light. Eventually, other explanations emerged. Dust clouds, cometary fragments, natural processes we don't fully understand. But the uncertainty remains. We still don't know for sure what's causing Tabby's star to flicker. And here's the question that haunts me. What if the reason we haven't found definitive proof of alien life is because we're not looking at the right things? What if we're searching for radio signals when we should be looking for dimming stars? What if we're listening for messages when we should be watching for construction? What if the universe isn't silent? What if it's screaming and we're just deaf to the sound? There's a concept in science fiction called the dark forest hypothesis. It's a potential solution to the Fermi paradox, and it's one of the most chilling ideas I've ever encountered. The hypothesis goes like this. Imagine the universe is a dark forest, and every civilization is a hunter hiding in the trees. You don't know where the other hunters are. You don't know if they're friendly or hostile. You don't know if they're armed or defenseless. The safest strategy is to stay quiet, stay hidden, and if you do detect another hunter, eliminate them before they can eliminate you. In other words, the reason we don't hear from alien civilizations is because any civilization that broadcasts its presence gets destroyed, and the ones that survive are the ones that stay silent. It sounds paranoid, right? But think about it from an evolutionary perspective. Any species that makes it to the stars would have survived countless existential threats on their home planet. They'd be cautious. They'd be strategic. They might even be ruthless. And if that's true, then the silence isn't a mystery. It's a warning. The universe is telling us, shut up, stay hidden, or die. And yet, here we are, broadcasting our presence, sending out radio signals, building the golden record, announcing to the cosmos, we're here, come find us. Are we brave? Or are we idiots? Maybe both. But the dark forest hypothesis is just one explanation. There are others, and some of them are even more disturbing.
Here's a thought that should terrify you. What if the reason we haven't found any alien civilizations is because there's something out there that kills them all? Something inevitable. Something we haven't encountered yet. This is called the Great Filter. The idea is simple, but horrifying. Somewhere between the formation of a planet and the development of an advanced spacefaring civilization, there's a filter, a bottleneck that almost no species makes it through. Most potential civilizations die before they reach the stars. Now the question is, where is the filter? There are a few possibilities, and none of them are comforting. Possibility 1. The filter is behind us. Maybe the hard part was getting started. Maybe life itself is incredibly rare. Maybe the jump from single-celled organisms to multicellular life is so difficult that Earth is one of the only places in the universe where it happened. If that's true, then we're incredibly lucky. We made it through the filter. The universe is ours for the taking. We just need to survive long enough to explore it. But there's a problem with this theory. We've found evidence that the building blocks of life are everywhere. Amino acids in meteorites, organic molecules in interstellar space, water on moons and exoplanets. Life might not be rare at all. Which brings us to the second possibility. Possibility 2. The filter is ahead of us. Maybe the hard part isn't getting started. Maybe it's surviving long enough to become a spacefaring species. Maybe there's something that kills every civilization before they can spread to the stars. Think about all the ways humanity could destroy itself. Nuclear war, climate change, artificial intelligence, engineered pandemics, asteroid impacts, runaway nanotechnology, or something we haven't even thought of yet. Every one of those threats is existential. Any one of them could wipe us out.
And the more advanced our technology becomes, the more ways we find to destroy ourselves. Maybe every alien civilization reaches a certain level of technology, and then, poof, they're gone. Self-destruction is the filter. If that's true, then the silence of the universe isn't a mystery. It's a graveyard. And we're walking through it, headed for the same fate as everyone who came before us. But there's a third possibility. One that's even worse. Possibility 3. The filter is both behind us and ahead of us. Maybe life is rare, but it does happen. Maybe civilizations do develop technology, but they always destroy themselves before spreading to the stars. Maybe the universe is full of planets with ruins on them, dead cities, empty monuments, graveyards of species that got so close but never quite made it. And maybe one day, billions of years from now, some other species will find Earth. They'll discover our cities, overgrown and crumbling. They'll find the golden record and wonder who we were. And they'll ask the same question we're asking now. Where is everyone? The Great Filter is one of those ideas that sounds academic until you really think about it. Then it becomes personal, because it's not just about aliens. It's about us. It's about whether we have a future. Every time we develop a new technology, every time we solve one problem and create 3 new ones, every time we look at the state of the world and wonder if we're going to make it, we're staring down the filter. And the scariest part? We have no idea if we've already passed it or if it's still waiting for us. But let's say for a moment that we're not alone. Let's say there are other civilizations out there, and they've made it through the filter. They've made it to the stars. They're exploring. They're thriving. Why haven't they contacted us?
One possibility is that they're avoiding us on purpose. Not because they're hiding, but because they're following a rule, a kind of cosmic non-interference policy. In Star Trek, they call it the Prime Directive, a rule that prevents advanced civilizations from interfering with less developed ones. The idea is that contact could be harmful, that it could disrupt a civilization's natural development, or even lead to its destruction. It sounds far-fetched, but think about it from their perspective. If an advanced alien civilization showed up on Earth tomorrow, what would happen? Mass panic? Religious upheaval? Economic collapse? Wars over who gets to control alien technology? Maybe they've seen this happen before. Maybe they've watched civilizations tear themselves apart after first contact. And maybe they've decided the kindest thing to do is wait. Wait until we're ready. Wait until we've proven we can survive the filter. Or maybe they're not waiting at all. Maybe they're already here. There's a concept called the zoo hypothesis. The idea is that alien civilizations know we exist, they're observing us, but they're doing it from a distance. We're like animals in a zoo, or specimens in a lab. They're studying us, learning from us, but not interacting with us directly. If that's true, then every strange signal, every unexplained phenomenon, every UFO sighting could be evidence of observation. They're not hiding from us, they're just watching. And honestly, that's almost more unsettling than being alone. But here's where things get really weird. What if the reason we haven't found aliens is because they're not where we think they are? What if they're not on planets at all? In 1960, physicist Freeman Dyson proposed a thought experiment. What would an advanced civilization do when they needed more energy? They might build a structure around their star to capture all of its energy output, a Dyson sphere. The idea is that a sufficiently advanced civilization wouldn't live on planets. They'd live in artificial habitats, massive orbital structures, space stations, ring worlds.
They'd dismantle planets to build more habitats. Eventually, they'd surround their entire star with a shell of infrastructure. From our perspective, looking at a star with a Dyson sphere around it, we wouldn't see a bright star. We'd see something dim, something that emits infrared radiation instead of visible light. We'd see something that looks almost dead. And here's the kicker. We've been finding stars like that. Dim stars. Red dwarfs, brown dwarfs, stars that don't quite add up. Could some of them be Dyson spheres? Could some of them be alien megastructures? Or are they just natural phenomena we don't fully understand yet? The answer is, we don't know. And that's the theme of this entire video, isn't it? We don't know. The universe is hiding something from us, and we can't figure out what it is. But I want to talk about something even stranger than Dyson spheres, something that makes megastructures look quaint by comparison. What if advanced civilizations don't live in our universe at all? Stay with me here. There's a hypothesis in physics called the simulation hypothesis. The idea is that our entire universe might be a computer simulation created by an advanced civilization. If that's true, then the real universe, the one where the simulation is running, might be completely different from ours. Different laws of physics, different dimensions, different everything. And if that's the case, then advanced civilizations wouldn't be exploring space. They'd be escaping space. They'd be moving into higher dimensions, virtual realities, simulated worlds where they have complete control. From our perspective, inside the simulation, they'd simply disappear. They'd stop existing in physical space, and we'd be left alone, wondering where everyone went. Now, I know what you're thinking. This is starting to sound like a conspiracy theory, and you're right, it does. But here's the thing about the universe. The more we learn about it, the weirder it gets. The deeper we look, the less sense it makes. Quantum mechanics tells us that particles can exist in multiple states at once until observed. Relativity tells us that time is relative, that it moves differently depending on your speed and gravitational field. String theory suggests there might be extra dimensions we can't perceive. The multiverse theory suggests there might be infinite versions of reality, each with different laws of physics. None of this makes intuitive sense. None of it fits with our everyday experience of the world, and yet it's all supported by evidence. So when someone says, what if we're living in a simulation, or what if aliens exist in higher dimensions, well, it doesn't sound that crazy anymore. It sounds like the kind of thing that might actually be true.
But let's bring it back to something more concrete. In 1996, scientists announced that they'd found evidence of ancient microscopic life in a meteorite from Mars. The meteorite, called ALH 84001, contained structures that looked like fossilized bacteria. The announcement was huge. It suggested that life had existed on Mars billions of years ago. It suggested that life might be common in the universe. It suggested that we might not be alone. And then, nothing. The findings were disputed. Other scientists argued that the structures could have formed naturally, without life. The evidence was inconclusive. But here's what nobody talks about. Even if those structures weren't fossils, even if they were just minerals, the fact that they look so much like fossilized bacteria is strange in itself. It means that the line between life and non-life, between biology and chemistry, might be blurrier than we thought. What if life isn't rare? What if it's everywhere, but it's so different from what we expect that we don't recognize it? What if there are organisms living in the clouds of Venus? What if there are microbes in the subsurface oceans of Europa or Enceladus? What if there are beings made of plasma floating through the atmospheres of gas giants? What if there are creatures living in the vacuum of space itself, surviving on radiation and cosmic dust? We've been searching for life like us, carbon-based, water-dependent, DNA-driven. But what if life in the universe is far more diverse than that? What if we're looking for the wrong thing? There's a term in astrobiology, biosignatures. These are signs of life that we can detect from a distance. Oxygen in an atmosphere, methane produced by bacteria, chlorophyll reflecting light. We're searching for these biosignatures on distant exoplanets. But what if alien life doesn't produce any of the biosignatures we're looking for? What if it's based on silicon instead of carbon? What if it breathes nitrogen instead of oxygen? What if it doesn't have DNA at all? In 2010, NASA announced the discovery of a bacterium called GFAJ1, which could allegedly incorporate arsenic into its DNA instead of phosphorus. If true, it would mean that life could be based on different chemistry than we thought possible. The findings were later disputed, but the question remains, how flexible is life? How weird can it get? And if life on Earth can be that strange, if it can survive in boiling acid pools, in Antarctic ice, in the high-pressure darkness of the deep ocean, then what might life be like on other planets? Maybe the universe isn't hiding alien civilizations from us. Maybe we're just not smart enough to recognize them yet.
Let's talk about something that keeps astronomers up at night. In 1977, astronomers discovered a structure in space called the Hercules Corona Borealis Great Wall. It's a cluster of galaxies so large that it defies our understanding of how the universe should work. How large are we talking? Try 10 billion light-years across. To put that in perspective, light traveling at 186,000 miles per second would take 10 billion years to cross from one end to the other. The entire observable universe is only 93 billion light-years across, which means this structure makes up a significant fraction of everything we can see. Here's the problem. According to our current understanding of cosmology, structures this large shouldn't exist. The universe isn't old enough for gravity to have pulled together something this massive. And yet, there it is. It's not the only one either. There's the Sloan Great Wall, a structure 1.4 billion light-years across. There's the Close Camposano LQG, a cluster of quasars stretching 2 billion light-years across. There's the giant GRB ring, a pattern of gamma-ray bursts arranged in a circle 5.6 billion light-years in diameter. These structures are so large, so organized, that some scientists have half-jokingly suggested they might be artificial. Obviously, no one seriously believes that aliens built galaxy-scale megastructures, but the fact that it's even a topic of discussion shows how weird these formations are. The universe has patterns, large-scale structure, organization, and we don't fully understand why. When we zoom out far enough, the universe starts to look like a web. A cosmic web of galaxies, connected by filaments of dark matter and separated by vast voids. It's beautiful in a haunting kind of way. It looks almost intentional. But it's not just the large-scale structures that are weird. There are smaller anomalies too. Things that don't make sense. Things that suggest the universe might not be as random as we think. Take, for example, the cold spot. When we measure the cosmic microwave background radiation, the afterglow of the Big Bang, we expect to see a mostly uniform temperature across the entire sky. And we do, except for one region. A massive cold spot, about 1.8 billion light-years across, where the temperature is significantly lower than it should be. Scientists have proposed several explanations. Maybe it's a void, a region of space with fewer galaxies than usual. Maybe it's a remnant of quantum fluctuations from the Big Bang. Maybe it's evidence of another universe colliding with ours. Or maybe it's a glitch. Some physicists have speculated, half seriously, half jokingly, that the cold spot could be a rendering error in the simulation we're living in, a place where the code didn't quite work right. Again, I know how that sounds, but the point is, we don't know what the cold spot is. We don't know why it's there. And the fact that it exists at all suggests that the universe might not be as uniform as we thought. Then there are the voids. When I say void, I don't mean empty space. I mean truly empty regions of the universe. Areas where there are almost no galaxies, no stars, no matter at all. Just nothing. The largest known void is called the Bootes void, and it's about 330 million light-years across. Inside this void, there are only about 60 galaxies. For comparison, a similar-sized region of space elsewhere in the universe would contain thousands of galaxies. It's called the Great Nothing, and it's disturbing not because of what's there, but because of what's not. Why would the universe have regions like this? Why would matter cluster in some areas and avoid others? It doesn't seem random. It seems designed. Of course, scientists have explanations. Gravity causes matter to clump together, which creates regions of high density and regions of low density. It's a natural process. Nothing mysterious about it. But when you look at maps of the cosmic web, when you see these vast voids surrounded by filaments of galaxies, it's hard not to wonder, what if this is all by design? What if someone or something organized the universe this way? I'm not saying I believe that. I'm just saying it's a thought that crosses your mind. Now, let's talk about something even stranger. The axis of evil. No, I'm not making that up. That's the actual term scientists use. When we analyze the cosmic microwave background radiation, we expect the patterns to be random. But they're not. There's an alignment, a preferred direction in space that shouldn't exist. Several large-scale features of the CMB all point in the same direction, toward the constellation Eridanus. Scientists call this the axis of evil because it challenges our most fundamental assumptions about the universe. According to the Copernican principle, the universe should look the same in all directions. There shouldn't be a special direction. There shouldn't be an axis. And yet, there is. Possible explanations range from the mundane, errors in our measurements, contamination from foreground sources, to the exotic. Maybe our universe is rotating. Maybe we're living in a multiverse, and this is where we touched another universe. Maybe the universe has a shape we don't understand yet. Or maybe it's a sign, a marker, a pointer toward something. What? We don't know. But here's what really gets me. The more we learn about the universe, the more we find things that shouldn't be there, patterns that shouldn't exist, structures that are too large, too organized, too specific. It's almost like someone built this place and then left clues behind. In 1999, mathematician and cosmologist Max Tegmark proposed something radical, the mathematical universe hypothesis. The idea is that physical reality isn't just described by mathematics, it is mathematics. The universe is a mathematical structure, and everything in it, including us, is just part of that structure. If that's true, then the patterns we're seeing aren't coincidences. They're inherent to the structure itself. The universe has patterns because it is a pattern. But here's the disturbing part. If the universe is a mathematical structure, then it's computable. It can be simulated. Which brings us right back to the simulation hypothesis. And if we're living in a simulation, then the strange structures we're finding, the great walls, the voids, the axis of evil, might be features, tools, navigation markers for whatever civilization is running the simulation. From their perspective, these structures might be as mundane as street signs or GPS coordinates. But from our perspective, trapped inside the simulation, they're cosmic mysteries. Okay, let's step back from the philosophical stuff and talk about something concrete, artificial structures in space. We've already mentioned Dyson spheres, but there are other megastructures that advanced civilizations might build. Ring worlds, massive rings orbiting a star with habitable surfaces on the inside. Shkadov thrusters, mirrors that use the pressure of a star's radiation to move the entire star system through space. Matryoshka brains, nested Dyson spheres designed for maximum computational power. These are all theoretical, but they're based on known physics. An advanced civilization could build them, given enough time and resources. So why haven't we found any? One possibility, we're not looking in the right places. Most of our searches focus on Earth-like planets in habitable zones. But if advanced civilizations build megastructures, they wouldn't need habitable zones. They'd build their habitats anywhere they wanted. Another possibility, megastructures are rare because they're unnecessary. Maybe advanced civilizations don't need that much energy. Maybe they figure out fusion or zero-point energy or some other power source we haven't imagined yet. Or maybe megastructures are common, but they look like natural objects to us. Maybe we've already cataloged thousands of them, but we don't recognize them for what they are. There's a star called Przybylski's star that has one of the weirdest spectrums ever observed. It contains heavy elements that shouldn't exist naturally, elements with very short half-lives, elements that should have decayed away millions of years ago. How are they still there?
Some scientists have speculated, and I want to emphasize that this is pure speculation, that Przybylski's star might be surrounded by an artificial structure that's producing these elements, a kind of cosmic factory. Is that likely? No. Is it possible? Well, technically, yes. And that's the thing about searching for alien megastructures. We're looking for something we've never seen before, using instruments designed to detect natural phenomena. It's like trying to find a skyscraper in a forest by looking for trees that are unusually tall. But every once in a while, something catches our attention. In 2018, astronomers detected an object passing through our solar system at high speed. They called it Oumuamua, which means scout in Hawaiian. Oumuamua was weird, really weird. First, it was shaped like a cigar, long and narrow, about 400 meters long and only 40 meters wide. No asteroid or comet we'd ever seen looked like that. Second, it was tumbling oddly, rotating every 7.3 hours in a way that suggested it wasn't a solid object. It might have been more like a chunk of rock loosely held together. Third, and this is the really strange part, it accelerated as it left the solar system. Not a lot, but enough that scientists noticed something was pushing it. With comets, that's normal. As they get closer to the sun, ice on their surface evaporates and creates a tail of gas that acts like a rocket. But Oumuamua didn't have a tail. It didn't show any signs of outgassing. So what was pushing it? One explanation, maybe it was outgassing, but the gas was something we couldn't detect. Maybe it was pure hydrogen, which is invisible. Another explanation, proposed by Harvard astronomer Avi Loeb, maybe it was a solar sail, an artificial structure designed to be pushed by starlight. Maybe it was a probe, or a piece of debris from an alien spacecraft. The scientific community largely rejected that idea, not because it's impossible, but because extraordinary claims require extraordinary evidence, and we didn't have enough data about Oumuamua to make that claim. But here's the thing, we'll never get more data. Oumuamua is gone. It left the solar system and it's never coming back. We had one chance to study it and we missed it. And that makes you wonder, how many other chances have we missed? How many other objects have passed through our solar system without us noticing? How much have we already overlooked? The universe is vast, and we're only just beginning to explore it. We've barely scratched the surface. And every time we look deeper, Every time we build a more powerful telescope or launch a new space probe, we find something that challenges our understanding. Patterns, structures, anomalies. The universe is hiding something, and I think, deep down, we're afraid to find out what it is. So let's get to the question we've been bouncing around this entire time. If the universe is hiding something, what is it? I've spent years thinking about this. Years reading papers, watching lectures, diving down rabbit holes, and I've come to a conclusion that I'm not entirely comfortable with. I don't think the universe is hiding anything. I think we're hiding from it. Let me explain. Every mystery I've talked about in this video, the great silence, the great filter, the strange structures, the anomalies, they all have one thing in common. They're about absence. About something that should be there but isn't, or something that is there but shouldn't be. We expect to find aliens, but we don't. We expect the universe to be uniform, but it's not. We expect natural objects, but we find things that look artificial. The universe isn't hiding. We're just not ready to see what's actually there. Think about it this way. Imagine you're a child, and your parents tell you not to go into the basement. You ask why, and they say you're not ready yet. You don't understand. You want to know what's down there, but every time you try to sneak down, something stops you. You get scared. You hear a noise. You convince yourself it's not worth it. Years later, you finally go into the basement, and you find out it's just storage. Old furniture, boxes of memories, nothing scary at all. The mystery wasn't the basement. The mystery was why you were so afraid of it. I think humanity is in that stage right now. We're standing at the top of the stairs, too afraid to go down. We're coming up with reasons not to explore, not to look deeper, not to ask the hard questions.
Maybe the universe is silent because we don't really want to hear the answer. Maybe we haven't found aliens because we're terrified of what it would mean if we did. First contact would change everything. Our religions, our philosophies, our sense of identity, all of it would be challenged. We'd have to confront the fact that we're not special, not unique, not the center of the universe. And maybe on some level, we're not ready for that. But here's the thing. Whether we're ready or not doesn't matter. The universe doesn't care about our feelings. It doesn't wait for us to be comfortable. The truth is coming, one way or another. Every year we launch new telescopes. Every year we discover new exoplanets. Every year we get closer to answering the biggest question in human history. Are we alone? And I think the answer is going to surprise us, not because it's what we expect, but because it's going to force us to redefine what we mean by life, intelligence, and civilization. Let me paint you a picture of what I think is actually going on. Imagine that intelligence in the universe isn't rare. It's everywhere. But it doesn't look like us. It doesn't think like us. It doesn't communicate like us. Maybe there are civilizations made of energy, existing as patterns in electromagnetic fields. Maybe there are beings that experience time differently than we do, living millions of years in what we perceive as seconds. Maybe there are intelligences spread across entire star systems, thinking thoughts so slow and vast that we can't comprehend them. I'm reminded of a thought experiment by Carl Sagan. He asked, if you put a radio in front of a medieval peasant and tuned it to a station, would the peasant understand what they're hearing? Would they recognize it as human voices, as communication? Maybe not. Maybe they'd think it was magic, or demons, or the voice of God. They wouldn't have the framework to understand what they're experiencing. We might be that peasant right now. But let's say I'm wrong. Let's say intelligence in the universe is rare, and we're alone in this corner of the galaxy. Let's say the great silence is real, and there's nobody out there to talk to. That would be lonely. Existentially lonely. But it would also be an opportunity. If we're alone, then the future of intelligence in the universe depends on us. We're not just another civilization among thousands. We're it. We're the only ones who can spread life beyond Earth, who can preserve consciousness, who can ensure that the universe doesn't become a cold, dead void. That's a heavy responsibility, but it's also kind of beautiful. The astronomer Carl Sagan once said, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." If we're alone, then we're the universe's only chance to understand itself. We're the only eyes looking back at the stars, the only minds wondering why anything exists at all. And maybe that's enough. But I don't think we're alone. I really don't. The universe is too big, too old, too full of possibilities for life to have happened only once. I think there are others out there. I think they're watching us, or ignoring us, or haven't noticed us yet. And I think we're going to find them. Maybe not in my lifetime, but soon. In the next century, maybe the next few decades. When we do, it's going to change everything. But until then, we're left with the mystery, the silence, the waiting. And that's what this video has really been about. Not the fear of the unknown, but the anticipation of it. The sense that something incredible is just beyond our reach, waiting to be discovered. The universe is hiding something. Or maybe it's not hiding anything at all. Maybe it's just waiting for us to look in the right place, to ask the right questions, to be ready for the answers.
I want to leave you with one final thought. In 2006, the New Horizons spacecraft launched from Earth on a mission to Pluto. It took 9.5 years to get there. When it finally arrived in 2015, it sent back the first high-resolution images of Pluto's surface. And you know what we found? Mountains made of ice, plains of frozen nitrogen, a heart-shaped region that's become iconic. Pluto, this tiny, distant world at the edge of our solar system, turned out to be beautiful, complex, geologically active. Before New Horizons, we thought Pluto was just a dead rock, a frozen ball of nothing. But when we actually looked, when we sent a probe there and took the time to observe, we found a world full of surprises. That's the universe in a nutshell. Every time we look closer, we find something we didn't expect. Every time we think we understand something, it reveals a new layer of complexity. The universe isn't hiding from us, it's inviting us to look closer. And that's what we should be doing. Not cowering in fear, not making excuses, not convincing ourselves that the answers are too scary to seek out. We should be exploring, questioning, searching. Because somewhere out there, in the vast darkness of space, there's an answer waiting. Maybe it's aliens. Maybe it's something stranger. Maybe it's a truth so profound that it will redefine what it means to be human. I don't know what we'll find, but I know this: the search itself is worth it. The universe is hiding something, and we're going to find out what it is, or die trying. And honestly, either way, it's going to be one hell of a story. So that's it. That's what keeps me up at night. Not astrophobia, not the fear of space itself, but something deeper. The fear that we're missing something obvious. The fear that the answer is right in front of us and we're too blind to see it.
but also the hope. The hope that one day, maybe soon, we'll look up at the stars and finally understand what we're looking at. If you made it this far, thank you for watching. I know this was a long one, but these are big questions. They deserve more than a 5-minute video. If you want to dive deeper into any of these topics, I've left links in the description. And if you have your own theories about what the universe is hiding, leave them in the comments. I read every single one. We're all in this together, trying to make sense of the cosmos. And maybe that's the real answer. Maybe the universe isn't hiding anything. Maybe we're just not meant to understand it alone. Maybe we need each other to figure it out. Until next time, keep looking up. Keep asking questions. Keep searching for the truth. Because it's out there, somewhere. And we're gonna find it. But wait, before you click away, I need to talk about something that didn't fit anywhere else in this video. Something that honestly makes everything I've said so far even more disturbing. We've been talking about what the universe is hiding. But what if the scariest part isn't what's hidden? It's what we're actively ignoring. There are phenomena happening right now, observable events that we can measure and detect that science has basically shrugged at and said, we'll figure it out later. Except later never comes. Because these phenomena are so weird, so outside our current understanding, that most scientists don't want to touch them. They're career suicide. Too strange, too controversial. Let me give you some examples. The Pioneer anomaly. In the 1970s and 80s, NASA launched Pioneer 10 and Pioneer 11, 2 spacecraft designed to explore the outer solar system. They completed their missions successfully, but as they traveled into deep space, something strange happened. They started slowing down. Not by much, just a tiny, tiny deceleration. But it was measurable, and it was consistent. Both spacecraft were experiencing the same unexplained force pulling them back toward the sun. Scientists scrambled for explanations. Solar wind? Nope, too weak. Gravitational anomalies? Doesn't match the math. Radiation pressure from the spacecraft's own power source? Maybe, but the numbers didn't quite add up. Eventually, after decades of analysis, they concluded it was probably thermal radiation from the spacecraft itself creating an asymmetric force. Problem solved, right? Except, maybe not. Because here's the thing, the explanation works mathematically, but it requires very specific assumptions about how radiation radiates from the spacecraft. Assumptions we can't verify because the pioneers are too far away to study directly. So what if the explanation is wrong? What if there's something else out there, something we can't detect, that's affecting objects as they leave the solar system? What if the boundary of our solar system isn't what we think it is? The wow signal revisited. Remember the wow signal from earlier? The 72-second radio burst from 1977 that we never heard again? Here's what I didn't tell you. In 2017, astronomer Antonio Paris proposed that the signal might have come from a comet, specifically Comet 266P Christensen. He argued that the hydrogen cloud surrounding the comet could have produced the signal. Case closed, right? Natural phenomenon. Move on. Except the original discoverer of the wow signal, Jerry Amon, rejected this explanation. He pointed out that the frequency was too narrow, too specific. Comets don't produce signals like that. The math doesn't work. But here's the disturbing part. Nobody followed up. Nobody tried to verify Paris's hypothesis. Nobody pointed more powerful telescopes at that region of space to see if it happens again. We just accepted the explanation and moved on. Why? Because if the comet explanation is wrong, then we're back to square one. Back to saying, we don't know what this was. Back to admitting that something unexplained happened and we have no idea if it will happen again. And science doesn't like unexplained phenomena. It's messy, it's uncomfortable, it challenges funding priorities and research agendas. So we sweep it under the rug and pretend it's solved. Fast radio bursts, the repeaters. We talked about FRBs earlier, but I want to go deeper on one specific aspect that's truly bizarre. Most fast radio bursts happen once and never repeat. They're one-off, random, unpredictable. But some of them repeat. And not just occasionally. Some of them repeat on precise schedules. FRB 180916 repeats every 16.35 days like clockwork. For 4 days, it's active, producing bursts, then it goes silent for 12 days. Then it starts again. FRB 121102 doesn't have a strict schedule, but it has a pattern. It produces bursts in clusters, then goes quiet, then produces more bursts. Natural phenomena don't usually behave like this. Pulsars are sure, but they pulse constantly, not in on-off cycles. Magnetars are chaotic, not scheduled. So what could cause an FRB to turn on and off with such precision? One possibility, it's an orbiting system. Maybe a neutron star orbiting something else, and the bursts only reach Earth when the neutron star is in a specific position in its orbit. Another possibility, it's artificial. A lighthouse, a beacon, a signal designed to be noticed. The scientific consensus leans towards the natural explanation, but here's what bothers me. The consensus is based on we don't have evidence it's artificial, not we have evidence it's natural. That's not the same thing. It's the absence of evidence for one explanation, not the presence of evidence for another. And in science, that should make us uncomfortable. But it doesn't. Because we don't want it to be artificial. We want it to be natural. Because if it's artificial, then everything changes.
Remember Tabby's star? The star that dims by up to 22% in irregular patterns? We said earlier that scientists proposed natural explanations, dust clouds, cometary fragments, etc. And that's true. Those explanations have been proposed. But here's what I didn't mention. None of those explanations fully account for what we're seeing. The dust cloud hypothesis works for some of the dimming events, but not all of them. The comet hypothesis doesn't explain the long-term dimming trend. Every explanation we've come up with has holes in it. In 2019, a team of astronomers published a paper suggesting that the dimming might be caused by circumstellar material, stuff orbiting the star, but they couldn't identify what that stuff actually is. So we're back to saying, something is blocking the light from Tabby's star. We don't know what it is. And then we stopped looking. Why? Because the Dyson sphere hypothesis, the idea that it might be an alien megastructure, got so much media attention that it became embarrassing. Scientists didn't want to be associated with that UFO star. So they proposed natural explanations that don't quite work, and everyone nodded and said, "Good enough," and moved on to other projects. But the star is still dimming. The mystery is still unsolved.
We just stopped caring because the alternative was too uncomfortable. What this all means. Here's the pattern I'm seeing. Whenever we encounter something in space that's truly anomalous, truly unexplained, we do one of two things. Either we propose a natural explanation that kinda sort of works if you squint and don't look too closely, or we ignore it entirely and hope someone else figures it out later. We don't like mysteries. We don't like admitting that we don't know something. So we paper over the gaps in our understanding and move on. But those gaps are still there. Those mysteries are still unsolved. And the more we ignore them, the more they accumulate. What if all these anomalies, the Pioneer anomaly, the WOW signal, the fast radio bursts, Tabby's star, the axis of evil, the cosmic voids, the great walls, what if they're all connected? What if they're all pieces of the same puzzle, and we're ignoring them because we're afraid of what the complete picture might show? I'm not saying it's aliens. I'm really not. But I am saying that there are things happening in the universe that we don't understand, and our response has been to shrug and say, probably nothing. That seems unwise. Because here's the thing about mysteries. They don't go away just because you ignore them. They accumulate, they pile up, and eventually you have to deal with them. And when we finally do, when we finally look at all these anomalies together and try to make sense of them, I think we're going to discover something profound. Maybe it's a new law of physics. Maybe it's a property of space-time we didn't know existed. Maybe it's evidence of intelligence in the universe. Or maybe it's something we can't even imagine yet. Something so outside our current framework of understanding that we don't have words for it. But we'll never know if we keep ignoring the evidence.
Okay, one more thing. And this is where it gets really philosophical, so bear with me. There's a principle in quantum mechanics called the observer effect. The basic idea is that the act of observing something changes it. When you measure a particle, you affect its state. Now, this is usually applied to subatomic particles, but what if it applies to the universe as a whole? What if the act of us observing the universe, searching for life, looking for patterns, what if that's changing what we find? Stay with me here. In quantum mechanics, particles exist in a superposition of states until they're observed. Schrödinger's cat is both alive and dead until you open the box. The famous double-slit experiment shows that photons behave differently depending on whether they're being observed. What if the universe works the same way on a cosmic scale? What if, by searching for aliens, we're collapsing the probability wave? What if the universe is in a superposition of contains intelligent life and doesn't contain intelligent life, and our observation is determining which reality we experience? I know that sounds insane, but quantum mechanics is insane. Reality at the fundamental level is insane, and we're only just beginning to understand it. There's a concept in physics called the participatory anthropic principle, proposed by physicist John Wheeler. The idea is that observers are necessary for the universe to exist, not in a mystical sense, but in a quantum mechanical sense. The universe requires observers to collapse quantum states and make reality concrete. If that's true, then we're not just exploring the universe, we're creating it. Our observations are literally bringing reality into existence. And if that's the case, then maybe the Great Silence isn't a mystery at all. Maybe there are no other observers because we haven't observed them yet. Maybe the universe is waiting for us to look in the right place, to ask the right question, to collapse the wave function. Maybe we're not finding aliens
because we haven't imagined them into existence yet. Okay, I know I'm getting into really speculative territory here, but here's why this matters. If observation affects reality, then the way we search for things determines what we find. We've been searching for life that looks like us, carbon-based, water-dependent, DNA-driven, living on rocky planets in habitable zones. So that's what we're going to find, if we find anything at all. But what if life in the universe is far more diverse than that? What if there are forms of intelligence we literally cannot imagine because our observations haven't collapsed those possibilities yet? The universe might not be hiding anything. It might be showing us exactly what we're looking for. And we're looking for ourselves, the anthropic principle.
There's another principle in cosmology called the anthropic principle. It comes in two versions, weak and strong. The weak anthropic principle says the universe appears fine-tuned for life because if it wasn't, we wouldn't be here to observe it. It's a selection bias. We exist in a universe that allows us to exist, so of course it looks designed for us. The strong anthropic principle says the universe must have properties that allow observers to exist, because without observers, the universe is meaningless. It's more philosophical, more controversial, but here's where it gets weird. Some physicists take it even further. They suggest that the universe might have multiple possible states, and conscious observers are what select which state becomes real. In other words, we're not just observing the universe, we're choosing which universe we observe. And if that's true, then the great silence might be a choice we're making. Maybe we're collectively deciding, consciously or unconsciously, that we're alone, because that's less scary than the alternative. Think about it. What would happen if we found definitive proof of alien intelligence tomorrow? Not microbes on Mars, not radio signals that might be natural, but undeniable, indisputable evidence of an advanced civilization. Society would change overnight. Religions would fracture. Governments would panic. The entire framework of human history, the idea that we're special, that Earth is the center of meaning, that our conflicts and achievements matter on a cosmic scale, all of that would evaporate. We'd have to confront our insignificance, our vulnerability, our smallness. Maybe we're not ready for that. Maybe on some quantum level, we're choosing not to see what's there because we can't handle it yet. The universe isn't hiding anything. We're hiding from ourselves. The final question. So here's where we end up after all of this. The universe is either silent because we're alone, or it's silent because we're not listening correctly, or it's silent because we're choosing not to hear. Those are three very different explanations, and I don't know which one is true. But I do know this. The answer matters. It matters more than almost anything else we could possibly learn about reality. Because if we're alone, then the future of consciousness in the universe depends on us. We're it. We're the only ones who can spread life beyond Earth, preserve intelligence, ensure that the cosmos doesn't become an eternal graveyard. But if we're not alone, then everything we think we know about ourselves is wrong. Our place in the universe, our significance, our destiny, all of it gets rewritten. Either way, the truth is going to change us. So maybe the real question isn't, what is the universe hiding? Maybe the real question is, what are we hiding from? And maybe, just maybe, the answer is ourselves. We're hiding from our own potential, from our own responsibility, from the terrifying and beautiful reality that we live in a universe so vast, so strange, so full of possibilities that we can barely comprehend it. And that's okay.
It's okay to be scared. It's okay to feel small. It's okay to stand under the night sky and feel overwhelmed by the sheer scale of everything. But we can't let that fear stop us from looking, from searching, from asking the hard questions. Because somewhere out there, in the silence between the stars, in the patterns of cosmic radiation, in the dimming light of distant suns, there's an answer waiting. And whether that answer is you're alone, or you're not alone, or something we can't even imagine yet, it's going to be the most important discovery in human history. So we have to keep looking. We have to keep searching. We have to keep asking, what is the universe hiding? Because the only thing scarier than finding the answer is never looking for it at all. Thanks for sticking with me through this journey. I know it got heavy, I know it got weird, but these are the questions that keep me up at night, and I think they're worth exploring. If you enjoyed this video, consider subscribing. I make deep dives like this on topics that most people are afraid to touch. And if you want to support the channel, there's a link to my Patreon in the description. Leave a comment with your thoughts. Do you think we're alone? Do you think the universe is hiding something? Do you think I've completely lost my mind? All answers are valid. Until next time, keep looking up. Keep questioning. Keep searching for truth in the darkness. Because that's what makes us human. That's what separates us from everything else in the known universe. We're the ones who ask why. And one day we're going to get an answer.